Hi, it's Brent, and today we're going to be finishing off the conversion of the Miller CP-300 welder. We're going from a three-phase welder. We're going to set it up so it can run on your standard 220-volt single phase. So this is what the work area looks like after the last time. We cleaned it up. This was a pretty disgusting mess. So now it looks pretty good. These are the tools you're going to need for it. You're going to need a screw gun. You need a drill bit that's missing at least 10% of your drills. You need a 3/8, a 1/2 inch, and a 7/16 socket. You're going to need a flathead screwdriver. You're going to want a zip tie gun. And let me tell you, gentlemen, if you have not used one of these before, you are in for a treat. Harbor Freight even sells one that's adequate. You'll probably want a tape measure. And then for electronics, you need a motor run capacitor in 130 microfarad. You want a 450 volt rating on it. Now, this is the only capacitor in this size and rating that I could find on eBay. It is listed as a motor run capacity. If you search for CBB 60 capacitors, they're listed as motor run capacitors. I feel as confident about using these as I do about reading what it says in Chinese underneath there, which is probably not what I need. We're going to try it. We'll see what happens, and if worse comes to worse, you get to see what happens when a capacitor explodes, and we'll order up some more and give another shot. I also got these terminals because I don't really love Crimp Terminals. They're Thomas & Betts as well, which is a brand that is near and dear to my heart. They're just a little hole with a screw. I don't know if I'm actually going to use those, but I got a bunch of them because they were there. You're going to need a crimping wire cutter or a regular wire cutter and a second set of crimpers. I have a good set of crimpers somewhere. Not here, of course. Some ring terminals. I was originally going to do it all with 8-gauge wiring, but I think that's really overkill for this. And after looking at the guide that I was looking, I went out and got some 12-gauge wire. So we'll keep an eye on the temperature of that. I've got a thermocouple reader around here somewhere, and we'll keep an eye on the temperature of that. See if that holds up. Some real Super 88, there we go. Some real Super 88 Scotch brand electrical tape. You know, for these permanent installations, the stuff you get at Harbor Freight for 67 cents a roll is probably not going to cut it. So we're going to start by actually disconnecting this main wiring. And that's just because we're going to be running this off of directly wired in at first because the receptacles haven't come in. So we're going to disconnect all this. We're going to remove all of these. And that will be it for the next step. We're going to remove all these jumpers, and this list here is actually going to mean nothing to you anymore, but we probably still won't remove the sticker. So I am specifically not using my impact gun on this because these are brass screws and they will absolutely fall apart if you hit them with an impact gun. So and if anybody doesn't mention this in their YouTube videos, trying to work for a camera and not for your face is it's tricky. So enjoy watching primarily. Here we go, I'll put that over here-ish, the backs of my hands. Oh. And because if you're really smart, you'd figure out that you don't actually have to remove the whole bolts because they're not complete circles. So just Now, I'm just tightening all these down so that even if I don't use them, I know that the connections are nice and tight and I won't miss anything later on. And also just for, just to let you know, by looking at what it was originally wired up for 3-phase 230 volts, for what that's worth. Alright, so that's step one. Now step two is going to be on the back side, and I think for this one we can leave the fan wired up where it is. I have this wiring diagram here, but this line here is essentially these pins here. So you see 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So 1, 2, and 3. And you'll have line 1, line 2, and line 3. And we can probably use a continuity tester to figure out which one is which. I'm not sure it matters in particular. In this application, because this is AC, your capacitor does not have polarity. Now, if it had gotten here, I would be putting a bleed resistor across the capacitor. That doesn't affect how the machine runs, but it makes it safe when you turn it off, so you're not storing power in the capacitor. And I'll go back and add those in later when they arrive, but I'm certainly not going to let it stop me from welding. So this is the original wiring diagram, and again you see the 1, 2, 3 in, and you can see it's the same thing as this is really. It's just a little bit different. There's your diodes to turn your AC into your DC. 6 of them because 2 for each phase. That's pretty simple. So obviously it's a slightly different version, but they made this welder for so many years. So on the inside of it though, you can see this and this jumper that hooks them all together. We're going to need to remove that. So there's 2 wires on the backside. Now the forum where the guy describes the Hass-Kamp process to do the conversion, he suggests not removing the screws and unbolting those, which is what I would have done. But it's mentioned 3 times not to do that, again, because these wires get very delicate with age. So next we're gonna loosen that up. I'll see if I can get you guys a good view of the action, and we're gonna snip those off. And we're also gonna cut off all the zip ties. I have the zip tie gun, so we can put them all back on and make it look nice and professional. But we definitely want to snip off all these zip ties just so there's less fighting us pulling this apart. Okay, so we're just going to take out this bolt, and I think that's what we need to do to get access to the back side. Keep on keeping on. So it's the bolt, the washer, the panel, another washer, the standoff, another washer, or the lock a standoff to the thing, a lock washer on the other side, and then your regular nut. And I like to put things back together in the same order they came apart. It makes it a lot easier to remember what you were doing. So, all right, so washer, spacer, lock, washer, nut. Okay. And got the side cutters here. Just be careful with the insulation. I try to stick it in between 2 wires so you can just trim real gentle. Or if my mother is watching this, really gently. Go. Those are fine. Wow. So yeah, you can tell already this thing, it doesn't want to wiggle around too much. So we are going to be awfully careful with this. All right, I'm gonna pull you out of the holster here and show you what the deal is, and then you're probably not gonna get a very good view of what I do to actually cut it. Okay, so it's really difficult to see back here, but there's this jumper wire and there's one other one that is just there where it says industrial on the wire. I really hope this can be seen. Those have to come out. After trying to pry on this a little bit, that whole thing, it doesn't want to bend. And quite frankly, I don't want to bend it. Cracked wires seem like a real problem. And this is just, yeah, and it's making popping noises. So we're gonna reach through the back as best we can. I'll probably rearrange on the other side, reach in there with the side cutters and just snip them off. You know, I'd rather remove them, but I'd rather not fix the problems associated with removing them. So we're gonna go around the other side, see if we can't sneak our way in there. Okay, so when I said there was only 2 jumper wires to snip off, I was lying. We also have to snip off the wire from the center phase as well. So, and that is the second one up, and my fat arms are not gonna fit through there, are they? Something like that, there we go. So, that's one of the jumpers there. I think I could sneak in and snip that off. Oh, it's real easy to get a good grip. All right, sneak my arm in through there, get on that, and wow, I usually have a decent grip, but this is not easy. Come on. All right, we're gonna stop this and come back where I've miraculously cut that jumper wire off, that center wire off, and there's another wire which I'll show you if I can. How about that? So we trimmed that off there, and then you can't see it because it's behind that wire, but I just snipped the end off that one and took that whole lug out just to avoid confusion. I did kind of find that I had to kind of like nip through half the wire at a time. I just could not get a good angle on there to really squeeze on those. Now, to all you saying, well, but there's a live wire exposed right there, and well, I don't really like it either. The only thing I would say to that is that all of these are live. All of this is live. I mean, you know, if you don't know, this is live at certain points of it. So like if you don't know what you're doing and your hands are inside a welder and it's plugged in, I don't suppose that's going to be what kills you. Okay, hopefully you can see this, but so there's the one last jumper in there. I did pry it away enough. Man, I do not like prying on that. And we just need to remove the jumper that goes from here, and you can't see the back of it, but it's just a loop. So the one from here to here. And at that point, looking at the main wiring diagram, we will have removed that wire and that wire, which sets us up to begin the conversion, and we shouldn't have to mess with anything else on the back side. I'm still not sure about the location of the fan connection, but when it fails to spin, we'll certainly know that we have to deal with it. So, right, just because I'm feeling generous, I'll show you, I'll let you watch me struggle my way through cutting these, which, man, these are some stout wires. So, and now that I've done this, just getting that one up there. I'm just getting, there we go. Now that I've done this, I can assure you that the instructions to not deal with that make perfect sense. And there's the other, there's the 2 little loops of wire. So it is, let's see if it says the gauge on it. 8 gauge, which is exactly what I was going to use for my own jumpers. And what I won't be using 8 gauge to connect up these because that's such little wire. I don't have any faith in these. So what I'm going to do next is I'll just set you guys up, and I'm just going to button this back into place, and we should be done screwing with the front. Okay, now we've done all the back work except for potentially the fan, but you can burn that bridge when we get there. And if you're paying attention, it's washer, plastic, washer. Oop, don't get away from me there, buddy. And I find personally a lot of times with, if you get a lock washer on the backside, all you really got to do is just hold it with a couple fingers till it gets a little bite. And then you don't have to try to sneak a wrench back in there. So I think we did this without abusing these too much. You definitely feel a squeak. Now that I've done it, I realize I didn't have to take off those zip ties. So you don't either. All right, let's take a look at the diagram. So this is connected to this terminal, and I'm guessing that'll be connected to that one. So it's kind of, this is L1 and this is L3 by the diagram, and then you can put these right there and they're in the right order. Now to do this, I just took a continuity tester and I went from here and checked all of these. And of course they came up as no connection because I don't have a continuity mode on this either, so I can't make a beep. Of course it showed up as no connection because the switch on the front wasn't on. So pro tip there. So you can see 0, and now it drops down to 0 connection. 0L means no connection, so they're all no connection. And I don't think I'll see anything from any of the other ones of these. So there you go. So you got connection. Just know that if you're trying to verify that this and this are connected, and then this and this, yes, awesome, are connected, you got to make sure the switch on the front is on. So otherwise you're going to be confused for a minute. Ask me how I know. So beautiful. So we're going to make a jumper from here all the way up to here. And we're going to make a jumper from there all the way up to there. And so that's connecting the two sides together, and then they're going to be using the capacitor to connect to here and here to put it out of phase to generate that leg you're looking for. I have to apologize if I'm saying anything wrong. Again, this isn't my original work by any means. I know the direction of flow matters, and that's what we're making up for. We'll get the stuff together. For these, I'm going to use the 8-gauge wire because I have it, and because I have those fancy little Thomas and Betts 18-gauge. Oh no, they say 14. All right, this is all going to be 12-gauge because that's what I have the right stuff for. So we'll get going on that. Just an aside, because I know these two wiring diagrams are different. If you can see, that says line, 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 but that 1, 2, and 3, we'll just call it for the sake of argument, comes in over and goes down to the second one. So that's how we're orienting ourselves based on that. And again, we've already removed this wire and this wire and this wire from the diagram. So we're going from 1 up from the bottom to 1 down from the top. I would suggest that you do at least what I did to verify locations and whatnot. And 1/4-inch stud will work great on those, so that you don't have to buy 2 sizes like I did. And I don't know if any of you have crimped wire before, but I like to make the crimp, you know, the wire just a little, so I extend it just a little bit through, and then you don't have any exposed wire like that. And insulated and non-insulated, and I like to put the point of what I'm going to use to crimp it right there, right on the top where that split is. I don't know if that's the right thing to do, but it's what I do. So, and really give it the stuffing, and I usually move over just a little bit and give it around too. Oop, that was a little too far over. Okay, that's fine. One thing I'd also suggest doing, just put it on there, just really yank on it. I've had tons of these come apart, mostly from using the wrong crimper in the wrong way and all sorts of other problems. You could also split that off and solder it. I considered that, but that would interfere with my instant gratification. So we'll do that another time. Probably never. Okay, so I'm gonna run these two jumper wires. I'm not sure if you can see that, but the two jumper wires, the long ones, I'm gonna run off the back side just because then we're kind of, I don't know, it seems to make sense to me. It's gonna look better that way. I would want to put the washer on top of that instead of on the bottom. Again, I don't think it's gonna make or break your whole world. All right. But it's just the way I would do it. And since I'm the expert making the video, who totally knows what he's doing, that's how we're gonna do it today. Okay. Now, you wanna tighten that well, but like, don't feed her the corn. She will not take it. Of course, then we'll find out that nobody but people in Maine say feed her the corn, but that's okay. I'm gonna try to make this look almost like I care. And give that a snip. Dodgy connection there will create what I would consider to be a, you know, an unfriendly amount of sparks. So I'm going to pause it there because there's only so much you want to see me put the other jumper in. I'm going to put just the jumpers in, and then we'll work on getting the capacitors prepped and mounted. Okay, so this is in, this is in. I'll have to add in the capacitor leads. So the capacitor, one of the capacitor leads will have to attach here. The other one will have to attach here. So I also realized, though, I missed these jumpers here, the 1, 2, and the 3 that just go from pin 1 to pin 6, pin 1 to pin 6, and pin 1 to pin 6. So I'm going to just go attach those in real quick, and then we'll put the capacitors in. Then we'll hook up power to it, and then we'll figure out exactly what I did wrong. So, Brent, you might be saying, hey, you said get out the drill bit, you say get out the drill gun, but you haven't done anything with them. Well, we're going to mount up these, despite the fact that I'm almost positive that they're going to explode. I have no faith in these. So, on the bottom of them, I don't think this has any other purpose other than a mounting lug. And we're going to take it, we're just going to drill a couple holes in the back here, so that when these don't work, we also have a few superfluous holes in the back of our machine. Because that's good too. A lot of people put them under here. I don't have a problem with that, but I am way too lazy to make a bracket, and popping a couple holes in the back and putting them down here looks pretty tidy to me, and it's what I'm going to do, so that's what I'm going to do. Okay, so now I got the capacitors mounted up. I would not tighten these very much. I tightened one to heard a little popping noise, and then I decided to back off just a hair. So these lovely connectors that don't look anything like what the eBay advertisement promised are wrong anyways. So we're just gonna snip those off and strip them back. And we're really gonna try not to remove any of the strands because these are from China. So if they are solid enough to work, if this is enough strand to do the job, there will not be an extra filament of copper in there. There we go. That looks okay. So, all right. Yeah, there we go. I do like to pre-tin all my wires before I solder them together. I think it's a good thing to do. You gotta drop them all on the floor as well. They just don't work as well if you get it all right the first time. Grab these two. Right. We should call this show "Watch an Idiot Struggle with Simple Tasks." Okay, so now we've got it. We think we have it hooked up, and we think we have power to it. So I'm just going to put this somewhere where you guys might be able to see it. And I'm just going to check. And you just check from the hot to the hot. They're both hot because it's 240 volt. We'll check from there to there. 246. That's exactly what we want to see. And we should see to ground like 120 or something like that. Yeah, half of it. Okay, so we've done what we set out to do. So I'm just going to turn it on and off real quick, just make sure nothing strange happens. That sounds a lot better. It's nice though, you'll be able to hear that throughout the remainder of this video. It'll just drown me right out and I'll end up shouting at the camera, but it works. Okay, so now we need to figure out what the pinout for the 24 volt power pin at the front of this is. I'm going to move things around in a minute and we'll reset and I'll show you. All right, so now we're going to have to check the output voltage on the receptacle on the front, and that should really give us a good idea if we have our voltage right, because if we wired our transformers wrong, the voltages here are also going to be wrong, I think. So I have a diagram right here. We'll try to put it up on the screen instead of that, and my phone shut off. So we're going to check from I to G, and there's no lettering on there, but you can see there's a little key in the top there, and that's how you can orient yourself. So the one right to the right of that is J, the one there is I, and then there's a space, and the one there is G. So from I to G, we should have 115 volts AC. So let's see if that actually works out that way. So just put the pin in there and put the pin in there and flip the switch on, and 120 volts AC. Perfect. All right, so I'm going to shut it off again, and then we're going to check the 24 volts AC output. Okay. Looking at the diagram, and again, that should be, we'll attach it somewhere as well. So G to A should be 24 volts AC. And A to B, which is going to be those two there, and you can actually look up and see that most of them aren't populated, so that kind of helps you know which one's which. But, and by not populated, what I mean is if you see a little silver in the hole, that means there's a plug there. If you don't, there isn't. So A to B is you close them together to engage the contactor supply. And K also is supposed to be chassis ground. So we're going to check from A, right there, to G, that one down there, and we should get roughly 24 volts AC. So let's see if that one works. So we got G and we got A. Beautiful. 24.3 volts AC. That sounds awesome. All right. So we now have a wired up welder. So the next step is we're going to have to hook up the wire feeder, and we're going to have to hook up the whip, and we're going to have to try. Well, that's definitely welding. It's definitely on single phase. And I definitely don't know how to use this welder, but I'm gonna figure it out, and we'll probably do a follow-up video once I've gotten it running the way I like it, and we'll see how it actually can work and perform. And if any of you have one of these hooked up to 3-phase and want to provide me some footage of how it's supposed to look, we can do some side-by-side comparisons, and that would really probably sell or unsell this modification pretty readily. When you're setting up your MIG welder, I had a lot of problems with my quality of my weld at first, and my first instinct is to blame the machine because I'm doing something with it. It was never intended to be done. But after looking at it, a few things I found on my power lead right there, you can see the connection's crappy. I got this sort of quick disconnect thing on there. That looks like hell. It all needs to be scrupulously clean, especially your ground strap. And in case of ground strap, I actually removed it, cleaned everything with Scotch-Brite, and then put this no oxidation paste on it. I already binned it, but the end inside this grounding clamp, the inside of this grounding clamp, oh, right there, was completely corroded inside. The wire was all green, so I cut a few inches back, re-stripped it, cleaned it all up with a wire, with like a circular wire brush inside, and reattached that, and that made a tremendous difference on the quality of my welds. The other thing I did is I'm using 045 ridged rollers, which are made for flux core wire, on this solid core wire that's 035. I have the right rollers on order, but they just take a while to get here. So the thing to do, especially if you're doing it like that, is you don't want to over tighten the rollers. I'll have a picture later. But when you over tighten the rollers, you put little ridges in there, but the ridges also mean that you're changing effectively the diameter of your welding wire, you know, every 60 thou, something like that. And that's going to really affect your arc stability as well. So I've redone it, and I just basically put it on full speed and set the tension until it would just grab but not slide. And now the wire coming out of my tip doesn't have those ridges. I think a lot of this pre-work is something that like a professional welder would know right off the bat. But I also think if you're a professional welder, you're probably not following this tutorial. You probably have 3-phase power, or you've just gone out and spent the money on the right machine. This sort of conversion, I gotta feel at the end of the day, regardless of how these video series ends, it's a home gamer conversion. It's not something that you would really want to do if this is your living. So anyways, that's just a little bit about like some of the problems I had with it. I also, and I gotta clean it more, but the inside of the welding clamp, you can see, is pretty pitted and corroded, and I cleaned that up a little bit, but I want to clean it up more, and I'll replace this ground clamp because it is pretty well done. So anyways, that's it.